Hey guys, and welcome back to Caribbean Tools. In this series, we're continuing the chemistry syllabus. We're looking at section 8, 2.2 and 2.3 in your outline, and that would be solutions, suspensions, and colloids. So let's get straight into the video. So what we're going to do today, we're going to look at the definition of solutions and examples, the definition of colloids and the examples, as well as the definition of suspensions and give some examples. After which we're just going to compare the solutions, suspensions, and colloids in an isotopy table. Okay, so solutions are described as a homogeneous mixture. Now in the previous video, we spoke about homogeneous and heterogeneous mixtures. We said that the homogeneous mixture looks uniform throughout the mixture. So just imagine you mix some salt water. Throughout the mixture, it's going to look consistent. And it's hard to differentiate the component parts of this mixture. So we say solutions are, a good solution is a homogeneous mixture like some properly mixed out salt water. Okay. So what we're going to do here, we're going to look at the different types of states of matter acting as solutes or solvents and give examples for each of them. Okay, so imagine a gas acting as a solute. Oh, before we look at the examples, let me define what solutes and solvents are. A solute is a substance that dissolves in a liquid or another solvent. A solvent is the substance that does the dissolving. For example, some salt water again, or solute would be salt, and our solvent would be water. The salt is dissolving in the water, so we say the salt is a solute, and the solvent is the water. Usually solvents are in higher concentrations, and solutes are in lower concentrations. Okay, so right here we have gas acting as a solute first, and we're going to dissolve this gas in some liquid. So we're dissolving a gas in liquid. A typical example of dissolving gas in liquid would be carbonated beverages or soda water, where you dissolve some carbon dioxide in some water and get soda. So I'm going to put soda water. So carbon dioxide is acting as a solute and it's dissolving in the water, which is acting as the solvent because it's doing the dissolving to give you soda water. So now we're going to look at liquid as a solute and liquid as a solvent. So we're going to put liquid as a solvent here, liquid. An example of a liquid acting as both a solute and a solvent would be your white vinegar, where ethanoic acid is a solute and it's dissolving in the solvent, which is water. So I'm going to put white vinegar. So now we're going to look at solid. We're going to look at solid as a solute and liquid as a solvent. Typical example, my favorite example, salt water or seawater. So the solid in this example would be your sodium chloride, and the solvent in this example would be your water. So solid acting as a solute, sodium chloride acting as a solute, and water acting as the solvent to give your salt water. The next example that we're going to look at is gas dissolving in a gas. So we have gas acting as a solute and gas acting as a solvent. A very common example of this would be air or atmosphere. So we have some noble gases, some carbon dioxide, some oxygen, some water vapor acting as a solute and dissolving in the solvent, which is nitrogen. So we say gas as a solute and gas as a solvent, and the example of this would be the air. last example that we're going to look at is solid acting as a solute and solid acting as a solvent. An example of this would be bronze, where tin is being dissolved in some copper. So tin is acting as the solid solute and copper is acting as the solid solvent. So we have solid as a solute and a solid as a solvent. And our example here is bronze. Tin being dissolved in copper. Great, so we finished solutions and now we're going to look at colloids. Now colloids are considered a heterogeneous mixture. If you remember from the last video, a heterogeneous mixture is inconsistent and the component particles are easily distinguished. So we say that colloids are heterogeneous mixtures. So I'm going to talk about some examples of some colloids. We have gels, emulsions, foam, solid aerosol, and liquid aerosol. An example of a jelly colloids is literally jelly, like your jams, your strawberry jam, your guava jam. So I'm going to put jelly. An example of an emulsion colloid is mayonnaise. An example of a foam colloid would be your whipped cream or your shaving cream. Your solid aerosol would be like smoke. And your liquid aerosol, a very common example of liquid aerosol is fog or clouds. So very important to note, the particles in a colloid are much bigger than the particles in a solution, but they're still too small to be seen with the naked eye. So you look at a colloid, and we're going to talk about other properties of colloid, but for now the particles are larger than the particles in solutions, but much smaller than the particles in suspensions. Okay, suspensions. Suspensions are also heterogeneous mixtures. The component parts are easily distinguished. An example of this would be throwing some dirt in some water, and you see the dirt settling at the bottom of the container. So that's our example of our suspension. We're going to look at 3 other examples of suspension right here. I think I already did one right here. Let me just draw that again. So we have your water, like here at the beach, and you see the water at the surface, and the sand sedimenting at the bottom. So okay, another example of a suspension would be oil droplets in some water. So if you have your water and you pour some oil on it and you leave it to settle, you're going to have a layer of oil being formed on top of the water because oil has a lower density than water. So it forms on top of the water, and we say oil and water are immiscible. You can't mix them, they can't dissolve in each other, they are immiscible. And the last example that we have would be some dirt particles in the air. So the breeze blows some dirt, and that is an example of a suspension in air. So we have an example of a suspension with a solid and a liquid and a liquid, and a solid and a gas. Okay, last, we're going to be comparing the different properties of solutions, suspensions, and solids. So we spoke about this earlier, and we said that the size of solutions very, 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 very tiny, very minute, smaller than the particles in colloids, which are also minute, and the particles in suspensions are relatively large. So we're comparing the particles to the particles in solutions and colloids. So we say that the particles in suspensions are relatively large. Okay, visibility. Since the particles in solutions are so minute, it's not easily visible with the naked eye or even a microscope. So we say not very visible with the naked eye or even a microscope. The particles in colloids are similar, they're not very visible with microscopes or the naked eye, not very visible. The particles in suspensions, however, are easily visible with the naked eye. So easily. Sedimentation. If you mix some salt water properly and leave it in a container to settle, there will be no sedimentation because the particles are evenly distributed. It's a homogeneous mixture. So solutions don't settle. There's no sedimentation. So I'm going to put no. In colloids, the particles are larger than the particles in solutions, but there's still no sedimentation. So the colloids are not usually sediment. They don't usually sediment. Suspensions, if you leave some dirt, water, and you shake it up and you leave it to settle, there will definitely be some sedimentation. Or even oil and water, if you mix oil and water and you shake it up together, you're going to see the oil settle at the top and the water settle beneath it. So there is sedimentation in suspensions. Now light passes through, I'm going to put a tick on the solution. Light passes through solutions because the particles are so very tiny, it doesn't block the rays of light from passing through. So we say that light passes through solutions very easily. Light scatters when they pass through the colloids because the particles are bigger than the particles in solutions. So upon reaching those particles, they tend to bounce off the particles and they scatter. So when you shine some light through a colloid, it's going to look scattered. Suspensions. That does not pass through a suspension because the particles are so large, it's going to be hard for it to pass through. Appearance. Because light passes through the solution so easily, it's going to appear transparent. Transparent means that you can see straight through it. So, appearance in solution, transparent. The appearance in suspensions would be opaque because there's no light passing through. Opaque. And the appearance in colloids would be translucent because there is little. Translucent because there is little light passing through. So this wraps up this video, guys.